Fundamentally, graphene is an extraordinarily exciting material. If you think about it in an ideal sense, we have a single layer of carbon atoms. What that means is, in terms of their chemical structure, we have electrical properties far surpassing any commercial material available to us. We have thermal properties, we have mechanical properties. They're all better than existing materials. With AMD, we've developed a method of taking nanomaterials from bulk crystals. So for instance, if we take a piece of graphite that comes out of the ground, we've developed a methodology where one can essentially shear individual platelets of graphene from the graphite. And then we use a liquid processing method to stabilize that graphene solution or other nanomaterial solutions. And that's basically the platform for a range of applications that we are looking at.
I think it's fair to say that in the early days, a lot of the early adopters in the graphene area were very focused on the production of graphene. The benefit of arriving slightly later to this and working with a team such as Professor Dalton is that they've been very much more applications focused, and that's where we've been spending our money and our time in developing applications which we feel have a true commercial outcome.
We are basically moving towards that gap between academia and industry, and that's quite an exciting thing. Instead of having to rely on the direct transition of what we think is cool in the lab and trying to make or push for an end application, we're actually solving problems. For a very large automotive company, we're developing an ink that not only gives you very high conductivity, but it's also very stretchable. So it could, for instance, predict failure in your tire. And that's a very interesting application for graphene because not many other materials, in fact, no other materials do that.
What we do have is a platform technology. We have a team of liquid processing engineers, and from this expertise springs a lot of opportunity. There are so many applications for this amazing technology in so many fields, particularly in the environmental area. There are of course defense areas, medical devices, and the automotive industry. Anything you need to be lighter, stronger, faster, better is going to be a place for nanomaterials.